All right. Good morning. Happy Sunday. It is a beautiful Sunday morning here in southern Arizona, United States. 4:51 a.m. 30 some degrees. What's temperature? Oh, 40 degrees this morning. Not too bad. Not too bad. Not too cold. Oh, but we are here. We are going to do day 18. We're going to try to do. Let's say I haven't been stopped yet. I haven't run into a problem I haven't been able to solve yet. But that doesn't mean I won't be able to. It doesn't mean I'll be able to solve this one. But I do enjoy these puzzles, and I've done a lot of them in my. These types of puzzles are so fun to me. Some people hate them. When I was in undergrad, I was the guy that loved the algorithms class. I've written a quote unquote solution manual to the Corman book. I wish I had the Corman book in here so I could hold it up. But I think I spent a summer, maybe 2 summers. But when I was in undergraduate, spent a summer trying to do all of the problems in that book, and I have a big book, a big journal, a big binder full of all of my solutions worked out. And then when I couldn't solve one, I would bring it to my professor and I would talk to him, and he'd help me work my way through them. So I loved those puzzles; they were fun. But that's how I got good at this type of puzzle. Was learning how to solve those puzzles, which are like more straightforward. You got to use that, and then reading. I have books of puzzles. Not like and you read through them, and then you figure out, okay, what data structure I'm going to use to solve this. And I don't always have a solution, but I've been practicing for many years, and so I often do have a solution. But let's look at day 18 here. Boiling boulders. You and the elephants finally reach fresh air. We convinced the elephants that it's going to be safe. You emerge near the base of a large volcano that seems to be actively erupting. Fortunately, the lava seems to be flowing away from you and toward the ocean. Bits of lava are still being ejected towards you, so your sheltering in the cavern exits at little longer. Outside the cave, you can see the lava landing in a pond and hear it loudly hissing as it solidifies. Depending on the specific compounds in the lava and speed at which it cools, it might be forming obsidian. The cooling rate should be based on the surface area of the lava droplets, so you take a quick scan of a droplet as it flies past you. This is your puzzle input. Because of how quickly the lava is moving, the scan isn't very good. Its resolution is quite low, and the result, it approximates the shape of lava drops by 1 by 1 by 1 cubes on a 3-dimensional grid, each given as its XYZ approximation. XYZ position, sorry, not approximation. To approximate the surface area, count the number of sides of each cube that are not immediately connected to another cube. So if your scan were only 2 adjacent cubes, like 1, 1, 1, 2, 1, 1, each cube would have a single side covered and 5 faces exposed, a total of 10 sides. All right, so we're counting the surface area of cubes. How big is my input? Can I just brute force this? I don't know that there's a non-brute force version. So like 3D modeling is not... Oh, we can totally brute force this. Yeah. There might be a cool version where you translate the cubes into vertices, and then as it builds up, you can know how many faces there are. I don't know. I haven't done anything interesting with 3D modeling, but I feel like there might be a clever solution there. But my solution All right, we're just gonna take all of these, we're gonna add them to a set, and then we're gonna loop through all of them and say how many faces do you have exposed, because it'll just check its neighbors in 6 directions. If it's covered, it doesn't add that face. If there's something there, it doesn't add the face. If there isn't anything there, we add a face and we just sum it up. So this one should be pretty straightforward, but I've said that before. So let's see if we can do it without too much trouble. All right, let's get our example input in here. We're gonna define a couple types. New file. We got a 3D position, public record position, int x, int y, int z. Then we are going to have a set of these. All right, so I don't even know. Let's create a class, or let's create something called the solver. Oops, let's rename that solver.cs. And it's gonna take in a set of position cubes. This is the position of all the cubes. And then we're just gonna public int exposed faces. And we just loop through all of them, I think. So int exposed equals 0 for each position p in cubes. Then we need to check against all the other positions. Let's create a little helper here. Public position north is going to be this with, or let's not call it north, let's call it up. Y equals this dot y plus 1, so we'll go up. We've got down. We have front. So this will be Z towards the camera. We'll call that -1. Back. We'll call this away from the camera. 2 more. Left. And right. And this will be x plus 1. So we have all of the different directions. We'll put these in a list. Public, position, neighbors. This should be a... We'll do IEnumerable, because that's what we like to do these days, right? And list, new array. I wonder if I have to put the word position there. Up, down, front, back, left, right. Oh. Okay. So we get our neighbors, our solver says for each position in our cubes, and for each position n in p.neighbors, if cubes dot contains n, and really want to say if it doesn't contain it, then we add that size. I think this is it, and then we just got to parse in our puzzle. Public, static. The second part's gonna be something crazy. Solver, parse, string array rows for each. Our input's super easy too. There's no crazy parsing for each string row in rows. Row dot split on a comma. Parse dot select int dot parse int array. G, happy so nice to see you, my friend. Happy Saturday. Is it Saturday right now? Or Sunday. Happy Sunday. Is it Sunday wherever you are in the world? And then dot to array. Oh, no problem, G. You don't have to apologize for missing them. I love having company, but the last 2 days were tricky. I did end up getting them. I ended up solving them. I stream at crazy times anyway. I think the last two, I solved the first part on stream. I may have solved the second part on stream for the last two. Yesterday I finished. Yesterday I ran out of time to finish the second part. I was embarrassed at how long it took me to do the first part. I had the right idea, I just kept having these little bugs in my code. So we have a hash set of position cubes. But I did end up, I had the right idea for the second part too, so the second part was pretty quick. Yeah, they required some interesting knowledge. I think I solved day 16 part 1 and part 2 on stream. I can't remember for sure. I think I got it at the very end, just like right before I had to go on day 16. Oh no, I didn't. I ended up yeah, I solved the wrong problem on day 16. I solved the problem where you could keep teaching more elephants to go and scan the cave for you. So I didn't realize that it was, I misread the problem. I thought you could spend 4 minutes to teach a new elephant, and then those elephants could go solve it for you. So I ended up getting like going down a whole rabbit hole. But I did end up getting it in the end. And this will be cubes.add position 0, position 1, position 2. New position. Yesterday wasn't that hard if you, well, let me take it back. Yesterday, if you recognize that it's just a graph problem and you're trying to detect a cycle in a graph, it's not too bad. Cool. Yeah, I did solve them both. Here we go. String rows equals file dot read all lines example. Solver equals solver dot parse rows. Console dot write line solver dot exposed faces. Let's see here. Yesterday's was fun. I liked yesterday's a lot. So we get 64. This one, I'm assuming there's some neat trick with 3D vertices, but I'm just brute forcing it. I think this might be the yeah. I think this is the fastest I've solved any of these part ones, with the exception of probably like the first day. Even the first day, I feel like it took me a little bit long. Thank you, thank you. We got part 1. The space is something small. Let's look at part 2. Something seems off about your calculation. The cooling rate depends on exterior surface area, but your calculation also included the surface area of air pockets trapped in the lava droplet. Okay. Instead, consider only cube sides that could be reached by the water and steam as the lava droplet tumbles into the pond. The steam will expand to reach as much as possible, completely displacing any air on the outside of the lava droplet, but never expanding diagonally. In the larger example above, exactly 1 cube of air is trapped within the lava droplet. So the exterior surface area of the lava droplet is 58. Okay, so we only care now about the outside. Nutella Sandwich. I love your screen name there. Welcome aboard. We just finished part 1 of day 18 of the Advent Code. We're on to part 2. Part 1 had us find all cubes that are not touching, all exposed faces, but there are faces on the inside of the entire object. So we're actually looking, we only want to get faces that are on the outermost edge. So I'm going to think about how to do this. I feel like I can do a search here. Some kind of a graph problem again. The last several days have been graph problems. I think we can sort of, if we find the bounds. All right, so here's my thought. If we find the bounds of our shape, we can do a search from so we wrap the whole thing in one big cube. So we found the bounding box for our lava droplet, and then we start on the outside and we do a search to find all of the cubes that they're touching the outside. So we basically do a search on the outside, and so if something's not exposed to the outside, it won't get added, and then we run our solver from part 1 on it. So that's my plan, is to create a bounding box to do it. Barry over on the YouTube channel, yeah man, thanks for asking. Barry says, thanks for replying to my comment. I wasn't aware that you have a live channel as well. I do. I like having, my idea with my live channel is to get students of mine to understand that you're not going to know everything right out the gate. So when you're solving a puzzle, I don't just know what I'm going to write right away. This is something that's hard for new developers to understand. Is I don't know what I'm going to do immediately when I sit down to code something. There's like this process. So I wanted to record. I like recording myself, and sometimes there's little nuggets of gold in my recordings, and I can chop them out and show them to my students. Say, hey, look, this is my thought process here. I went down this hole. I got stuck. It's important for people to see the process. But yeah, Barry, thanks for stopping by. We're working on part 2 of day 18. You're welcome to hang out. I know that you're working on other parts, so if you don't want spoilers, I don't want to encourage you to leave. But if you don't want spoilers, now would be your time to hop off the ship until you're ready. The big F stream. Gee, I don't quite understand. Today's about the big F stream. I don't quite understand that comment. Oh, BFS? Breadth first search. Gotcha. Gotcha. Yeah, so essentially I'm gonna go on the outside and I'm gonna create a cube that's my bounding box and then find the exposed and then I can just run solver one on it again. Um Ooh, flood fill 3D. Yeah, exactly. Exactly. All right, Barry. Thanks for hopping in. Have a wonderful day. Good luck, and we will. If you ever need anything, feel free to. You're always welcome. You're always welcome. Let's go here. So I want to. Bounding box. All right. So for a cube's bounding box, I need. Um. My brain. I'm gonna have to visualize. I'm gonna have to draw this out. Yeah, yeah, go ahead. Spoil 17. So 17 and 16, that's fine. I finished them. So I have solutions to 17 and 16, so you're not spoiling them for me. Um, so so just so everyone knows, we're about to get some spoilers. If you're watching this for 16 and 17, I kind of spoiled it a little bit. Um, at the start here, just talking about how my solution works. How many points are on a cube's outside? I'm drawing a picture of a cube right now so I can reason through all the positions. I got 1, 2, 3, 4, 5, 6, 7, 8. That's what I thought. I thought I'd have eight positions. Yeah, yeah, Nutella sandwich. The advent of code is an advent calendar. So, I don't really know what Advent is. I know that it's a Christmas thing. I think it's a Christmas thing. We did it when I was younger. My family celebrates Christmas. You have these calendars starting on December 1st, leading up to the Christmas day, and every day you open up one of the little doors or one of these little things or mark something off, and usually there's like a little piece of candy or something in there. And so in December, this is my first year doing it, but I think it's awesome. This guy Eric Wassel um, gifts the world with these little puzzles. So every day there's a new puzzle and a neat little cute little story that comes out. Um, yeah, yeah, G, that's exactly right. Day 17. Yeah, Nutella sandwich. That's right. You can do them in any language you want. Really, you can even do it by hand if you really wanted to, and you could figure out how to do it mathematically. The You don't submit your code online, you just submit your answer. You find a solution and you submit your answer. It's a lot like if you've ever done Project Euler. Project Euler is the same way. So these are awesome. This has been so much fun. It's been a little intense. I don't normally do this difficult of a puzzle every day. So the last couple days have been kind of intense here. Yeah. It's coming up. I guess there's different ways you could find the repetition. But it's about coming up with day 17 yesterday was about finding if you encode it as a graph, every state of your game, if you encode it as a graph, you just detect a cycle. Yeah, actually day 17, I heard some people solved day 17 by hand by running their puzzle and then like manually detecting their cycle. Which I thought was probably a faster way to do it in some cases. All right. I need to find my 8 points. Public. I'm gonna create a new type. Bounding box 3D. Public record bounding box 3D. It says 8 positions. I don't even know what I would call these. Position. Need 8 positions for my bounding box. I wonder if there's just like a built-in bounding box program I can do. Anyway, my idea is I'm just gonna keep growing my bounding box until I have them all. So let me show you mine real quick. I'll show you what mine was a little awkward, but here's my solution. Real quick, I'll show you how I detected the cycle in mine. Sorry anyone who was so I have my simulator. Here's the like final solution. It got a little crazy here with giant numbers. But the idea is I encode a like graph. These aren't edges, these are actually nodes in a graph. This should be called nodes. From state to state. So every time I look at my top row, so my top row has some state. I have the piece that I'm currently dropping. The moves that piece is gonna make before it lands, and then an ID. This is like where it is in my Jetstream input. So like those are the things that matter. So if your top row is the same, if you've seen this top row before with this piece, in fact, I don't even need this moves thing. It could just be this ID with this specific position in my, oh yeah. So I could simplify this. It's funny when you come back to a puzzle and go, oh, I don't even need this thing here. The reason I have this is so I can simulate it again. But this is like the position I am inside of my Jetstream input. And so the second I see that again, so every time I do a move, I add my state and have my previous state add an edge saying, oh, this state goes to that state. And then if I have already added this state previously, I know I have a cycle. And so then I just go through and say, okay, find that cycle, go through, pull that cycle out, calculate the height of the cycle, and then add it all in. And then there's a little bit left over. And then you say, okay, and then plus the first 7 things of this cycle or whatever it was. I don't know if this was a particularly good explanation, but that is that's how mine worked. So I think that is the most from a it's not the most efficient from like data structures go, but I think it's the most efficient way to solve it. As far as just like the conceptual. You just keep building up your state, and as soon as you find a state that loops back. So you have like this graph that just is linear, so it's just a list. And then as soon as you find a thing that goes back, it says, oh, if I go back to this state, I can just repeat this, and you can fast forward it. Just repeat that chunk over and over without actually repeating it. Before I come, I need a position. I don't know what to call these. These values. So for now, I'm gonna do. Let me look. 3D bounding box position names. What are the coordinates of a bounding box? Like, what do they call them? Oh, this is so much smarter than what I'm about to do. Min x, int max x, int min y, int max y, int min z, int max z. I'm so glad I googled that. I was about to do something really, really dumb. Yeah, mine I think had something similar to that. If I were to run it again, we would. Is it? Did I leave this open? Um, what is mine? Here, we'll just run it real quick. Projects. My cycle height. So there was a 1,730 rocks in my cycle, and then here's all the math to do it again. I need to run this many cycles, and then I need to actually. So this should actually say I need to drop this many rocks. Smab, happy Sunday, my friend. And then there's 92 additional rocks I need to add at the very end. So yeah, so I have to, there's like this extra little chunk of rocks at the end that I have to add up to get my final height. Yesterday's puzzle I thought was really fun. If you don't know if you haven't done a lot of graph problems before, or like thought about how do I encode state into a graph, it can be challenging. Smab, you went ahead and did day 2. Or day 17. I'm so happy to hear that you went through and actually and did it. It was fun. I thought yesterday's puzzle was super fun. You add in a little rock bottom. I like the name rock bottom. Did you write a program to spot the cycle, or did you just do it and then take a look? So I heard some people actually just drew it out, like printed it out and then like found theirs. Let's look at what you did for solution 2, part 2. Chamber, drop rocks. I'm gonna search for part 2 here. I want to see how you did part 2. Solution 2. Yeah. Drop mini rocks. I don't know how people did it by hand, but supposedly people did it by hand. You can do it by hand for the example easily. The example has like a 35 height thing. Detecting so I guess my height was like 2,000 or something. Next jet direction. Repeat shape count, yep. If I've seen, exactly, this is exactly right. If, cool. I had to figure out the math, I had to like write it out on paper to be like, what am I doing here? And then I eventually encoded it all as like U-longs in my code. The numbers were so giant. First time is true. This is so interesting that you can do this. The first time is true. Detecting cycles, yeah. So this is just like good. I think so. It's so hard. I wish sometimes I love teaching young students. So I teach in middle school. I teach ages like 7 to 17. The school I work at actually doesn't have like grade levels. But my quote unquote middle schoolers, the students get to opt into my class, so it's not like in college someone's doing a computer science degree and it's like, oh, this is part of the curriculum, you have to take this class. So I only get students who really want to be there, and I can sort of have the prerequisites be whatever I want, And I usually have a little test for my students to let them know, and they understand, oh, if I can't pass this test, I'm not going to enjoy this class. Um, so I would love, what I was going to say is I'd love to teach an actual like college level algorithms and data structure class, that it's like just an algorithms class and we're using data structures. But I don't think enough students would be interested in signing up. So what I'm doing next term I'm teaching a class called Intro to Competitive Programming. And so it's this opportunity to explore some of those things, but in the context of solving like puzzles like these. Nice work on this, Smab. This code's a little gnarly for my taste. The indentations get a little bit crazy, but that's fine. It's fine. Yeah, nice. Well, I mean, 1, 2, 3, 4, 5. Even with 5, 6, 7 indents. I know. I don't know why the indent level is. Oh, it's because it's using tab. That's what it is. How do I change that? All right, I feel GitHub change indent size. Here we go. Change size. Why would you manage your tab size render preference? It's under settings. All right, let's go to GitHub. Settings. Tab. Where is settings? Settings. Tab. Where do I click? Tab size appearance. There we go. Appearance. You also helped me. I think you're the one that sent me the. Why would 8 be the default? That's crazy. Does anyone else think that 8 as the default is just absolutely insane? There we go. Still a lot of indent levels. But I don't know why 8 is the default. That's wild. Yeah, Tetris is a problem. Tetris is one of my favorite things to code. Super fun to write Tetris. It's one of the first things I usually do if I'm learning a new language. If I'm going into a new language, one of the first things I like to do is write Tetris, in one way or another. I think I want to make a tutorial on making Tetris. That's one of the things I want to do, is make a console version of Tetris and show then how you can take, if you design your framework properly, take that console version and then do it in something like Unity, or create a GUI for it. So create your data model. If you do your data model well, you can have a console Tetris app, and then very easily create a Unity or like a GUI Tetris app. Okay. Oh, let's keep going here. Smab, I finished part 1. Part 1 is super straightforward. I think part 2 is going to be not so bad as well, but I'm doing part 2 of today. I don't know if you've solved day 18. Part 1 was detecting, you have cubes and you're detecting which faces are not touching another one. Part 1 was trivial. Yeah, I think it's the shortest one. I think it took me less time than day 1 even. Part 2, my idea, so I haven't done it yet. My idea is to build a bounding box around my shape, and then just do a search, fill it up, find all the things within my, so you do it, I guess a flood fill is the, I didn't think of it as a flood fill, but do a breadth first search to find all of the exposed walls on the outside, and then you do the same thing for those cubes as you did in part 1. Yeah. It's just breadth first search. Flood fill is just a breadth first search, so we gotta do a search from the outside to find all the cubes that you can touch from the outside. But yeah, I gotta build my bounding box first. So public static bounding box 3D takes in a hash set of position, shape, and then we're gonna loop through find. So we're gonna loop through position P in shape, and we keep track of all our variables. Int min x equals, can I do min y equals 0? Can I do this? All right, we're gonna do x oh, these should be max. I normally don't do this, but there's so many of these on one line that I'm gonna do it. Ugh, why can't I type the word max? Min x equals min y equals min z equals int dot max value, max x equals max y equals max z equals int dot min value. I've mapped a slice rendering of my shape. It's a regular hollow sphere, but I think it has some extra pockets I haven't detected. So my guess is it's a little too small. It looks pretty like a CT scan. Ooh, that's cool. I think yeah, I hadn't thought about visualizations for this one. This visualizations would be really, really cool. I don't check Reddit until after. I try not to check Reddit until after I've solved it, or I know how I'm going to solve it. Yeah, so I'm starting from the outside and just finding all the things that are on the outside. That's sort of what I'm doing. And then we just update each one of these. Min x equals dot min is p is min x p dot x. We gotta do it for each one of these. Min y, min z. This type of code is so prone to terrible copy and paste bugs. Can we change the word? Limit it here. We're gonna change min to max. Close, almost had it. Okay, and then return new bounding box 3D min y min z max x max y max z. So we have a 3D bounding box, and we're gonna pick a corner and just scan into it. I'm realizing right now that my bounding box needs to be slightly bigger, because otherwise it's going to hit an edge, right? So I need to expand my bounding box. It needs to have a padding of 1. So public static, we'll add a padding. Public bounding box add int amount, and I really only need to do 1 padding. So turn new bounding box 3D. My min x minus amount. Yeah, min y minus amount. Min z minus amount. Max x plus amount. Max y plus amount. max z plus amount. Yeah, that's essentially what I'm doing. Is I'm finding a glass container, I'm putting it in there, and then I'm surrounding it to find all the positions. Yeah, I'm checking just the outside. So I want to find all of the shapes that are on the outside. Ooh, what's interesting is my solver for part 1 actually isn't going to work. So I was thinking then I would just run it against my solver, find all the exposed faces, but then it'll also find the face on the inside. So I need to keep that outside shape and then check which faces touch that outside shape. Yeah. So I almost did this wrong. So my solver for part 2, so I have my bounding box. Now I need to pick a corner and do a fill. So public hash set position fill. Oh, this is... I'm gonna have to do another breadth first search. So the idea here is I'm gonna get all of the positions that are on the outside of my cube. Oh, so I gotta do breadth first search correctly. And do breadth first search correctly. All right, Smab. We'll see in a bit. Do I really have to do another breadth first search? I think so. So I have to create a hash set of positions visited create a queue of position to visit Well, so I could just my goal is to be able to remember these things without having to go look them up. So I'm doing this breadth first search. Yeah, I'm gonna do this breadth first search without going and looking at how to do a breadth first search. So I think I can do it. So to visit dot add. Well, I need to get my bounding box. All right, so bounding box 3D box is equal to bounding box 3D dot find cubes. Okay. And then I need to pad it 1. And then I need to get like the one of the corners. So position corner equals new position box dot min x box dot min y box dot min z. So one of the corners, and that's where we're gonna flood fill from. So we say visited has the corner in it to start, and then to visit dot append in queue corner. And then while we have positions to visit dot count greater than 0. I think at the end we just return our visited things. We pop that guy off. We say, let's visit it. Position key equals toVisit.DQ. So we're gonna visit that position. We need to get all of its neighbors. So then we're gonna say for each key.neighbors for each position and in our neighbors. This is where I messed up last time on day 12, and I was stuck forever on day 12. Is I somehow forgot to add my neighbor here. I was adding it here. I was adding my neighbor here, and so it would eventually finish. It would eventually find it, but it was spinning forever. So we add our neighbor, saying we've seen it. If actually we don't add our neighbor yet. We actually want to. There's a condition that says if cubes dot contains n. We don't want to add it. So we skip cubes that we contain, and we skip cubes that are outside of our bounding box. So I'm going to write a contains here. Public bool contains position key. Okay, so I got to make sure it contains. So if p dot x is greater than or equal to min x, and p dot x less than or equal to max x, and we do this for each of the positions y and z. Y, z, y, and I'm not writing any tests, which makes me always nervous. Oh, return. This should not be in here. Okay. Yeah. So you just, if you've already, you just go out and you only add in the neighbors you haven't seen yet. Bloodfield is just Brett for search. Dota, happy Sunday, my friend. So nice to see you. And we're gonna say if our box dot contains n. If it doesn't contain n, we're gonna skip it. We are working on day 18 of Advent of Code. We got part 1 done. We're thinking part 2 is somewhat close. All right, so now that we know that we need to visit this one, visited.add n. Oh, you can do it. You can do it. You can do the first couple days. Dota. All right, if you're nervous at all right, so you can do it. My students, I've been having my students do it. YouTube, Captain Coder. All right. The first 14 days, I promise you can do. The first 14 days, I promise you can do. I have created beginner's guides to it. Go do day 1. If you get stuck, go watch my beginner's guide. Then do day 2. So I've been putting together beginner's guide. I've done the first 14 days as guides. Day 15 is the first day that I think that there's a concept. There's so many new concepts compared to the previous days that there's not a, quote unquote straightforward beginner's guide. I'm planning to do all of the days. Today I'm actually going to put together a beginner's guide for it, because today I think anyone could do with the right strategy. It's all about having the right strategy. But yeah, check out my guides. I promise you can do it. Anyone who knows how to do loops, arrays, functions, and Boolean logic. There's not a lot you can get super far up to day 14 with just that. And then it's a great opportunity to learn about like how sets work and dictionaries. So I promise you can do it. I promise you can do it. Okay. This is how I messed up my Brett first search last time. I was like I was writing it and then I'd come back, I'd get distracted. All right, so to visit. If we've already visited it, visited that contains and continue. See, I was about to make another mistake. NQN. All right, I think this is Brett first search. We should end up with a flood fill here. Our visited should contain all of the things surrounding our cube. And now we're just gonna find touching. All right. Public hash set. Oh, this is a little trickier. All right, so but we have this fill. So the idea is that if our fill method works, we have the shape around it. And then okay, all right, so now my I want to think. Okay, yeah. Here we go. Now that I have my fill, I have a public int faces touching fill, and we're going to take in a hash set position build. So this is our container positions, and we're going to say we're going to do this same thing, but rather than checking if it contains cube, we can check if filled contains it. So if the outside shape is one of the edges, then we add it to exposed. All right, my ideas here, I haven't tested it. Yeah, so anything that's touching that exposed area is exposed. Hopefully my fill is correct. If not, this is like the spot where I'll start testing first. All right, so this was part 1. Void part 1. Let's run this again. Make sure I didn't break my part 1 real quick. I didn't call part 1. I don't think I changed anything, so part 1 should still work. Okay, so let me commit that. Implemented quick version for or hacky version for part 1, day 18, part 1. Then let's do part 2. So we'll do it here. Part 1. That. Void part 2. So same thing, we're gonna build in a solver, but we don't solve it right away. Instead, we create a bounding box 3D. Or did I actually already do that in my solver? I think I did. My solver now just has a fill and then faces touching. All right, so we end up with a hash set position build equals solver dot fill, and then int exposed is equal to solver dot faces touching fill, and cross our fingers, not exposed faces. It should just be that. With I almost botched this here. Exposed. Right on our example, give ourselves at least a little confidence that it's, oops, don't want to commit again. Oh, we gotta call part 2. Ooh, okay, nope. Oh boy. All right. We've got... Yeah, so something has gone wrong, right? All right, let's see if we can eyeball it real quick. So we're gonna say for every position... if filled contains end. I had a not here. Ooh, Dota, cool. Is it in the same repository? Oh, come on. Cool. It might take me some time because of all of these Advent of Code things I'm doing, but I'm gonna get there. I really want to check it out. My brain is just elsewhere right now. What's going on here? I'm gonna have to write some tests. I think it's awesome. I think it's awesome that you've done that. I'm really interested in checking it out. For each of the cubes in my solver, so that's all of the cubes from my input, get the neighbors, and if my filled contains it, hang on, am I reading the wrong? Instead, consider only cube sides that could be reached by the water and steam. As the lava droplet tumbles into the pond, the steam will expand to reach as many as possible, completely displacing any air on the outside. I think this is... My fill has to be wrong. Have I done my fill incorrectly? Yeah, so I was thinking of doing that. I was gonna put the test I think I might do is a single cube. Does it flood fill properly around that? I'm just noodling around in my head real quick whether or not there's just like a straightforward logical bug I have here. But yeah, so I get the neighbors of my shape and I check, is that contained in my fill? If it is, I increase exposed by 1. 1 second. Let's see. Did I do my fill wrong? Fill contains cubes. Yeah, that's what I was gonna do real quick. Yeah, so something's gone wrong with my fill for sure. So let's print out my bounding box. Well, my fill is just... Yeah, my fill is super wrong. So my fill should contain more than 4 cubes. 0, 0, 2, 0, 0. All right, so in the example, our min x, if we subtract 1, do I need to pad by 2 for some reason? Here, let me try padding by 2. Is my pad right? Min gets smaller, max gets bigger. Let's try this. No. Okay. So my fill is definitely wrong. For this puzzle, Dota? Yeah. So here it is real quick. While you're looking at it, I'm gonna think of it about it over here. So the basic idea with part 2 is that your droplet has is not solid. It's not solid. There are things on the inside. And so you want to find my strategy is to create a bounding box around my shape and then fill that in with stuff and then determine which of those is touching my outside. Cool. Thank you, G. I appreciate that. So I got to figure out what's going on with my fill. Which is definitely where my problem is. I do have to. Oh, sorry. There's something going on. I gotta step away for 2 minutes, maybe less. I'll be right back. Sorry, I'll be right back. I'll leave this up in case anyone else wants to look at it. And I'm back. Sorry about that. Yeah, only what you can see from the outside. So I suppose another strategy would have been to fill in the inside and then check again. I think that'd be harder because you could have like a bunch of pockets on the inside. So you want the sides that are exposed to the outside. All right, so I'm gonna write a test here. My idea for the test is I'm gonna have a single dot, and my fill should contain every direction. And then I'm gonna do one with a 4x4, and my fill should be a little bit different. So I'm gonna write a test. Let's rename this to fill test, just because I don't want to flounder around too much, and I want confident once I have it working that it is working. Test fill. All right, so I'm gonna create a solver s new solver, and it's gonna have a single cubes. So hash set of position cubed equals new hash set, and I'm gonna give it a single position at 1 1 1. So my fill, my bounding box, I'm gonna give it a bounding box it should be just the cube that's in one in every direction. All right, so if I do my solver, dot fill, like this, so my hash set position fill should have what is that? 1, 2, 3, 4, 6. Should have 6 things. Oh no, my fill is gonna have more than 6 things. My solution should have 6 things, but my fill should contain the whole area around it. I think testing is a good thing. All of my I force my students to write tests. Well, I've worked for companies that do Agile, and it depends. I think it depends on what your product is. I think Agile can work really well on products that are constantly changing. If you have requirements and they're set and they're not going to change, Agile's useless. I've worked for companies where the requirements change from week to week. So Agile is very useful when your requirements change very quickly. Can work. You have to be on it. The other thing is Agile only works for small teams. I don't think Agile works for big teams. All right, so my fill should contain assert equal 1, 2, 3. All right, so then let me do solver dot faces touching fill. This should be 6. Result and expected 6 assert dot equal expected result, because each of the faces should be seeing it. The fill really should contain 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 26. Well, so it's only the faces that diagonals don't count, do they? So the cooling rate depends on the surface. So it's only the faces of the piece that are exposed. The steam will expand to do it in a larger. But your calculation also includes the surface of the pot. Instead, consider only cubes that could reach the water by steam drop. Showing the steam will expand, placing the water outside the drop, but never expanding diagonally. So it's only orthogonal. Yeah. No, the outside of a single cube isn't 8. It's 26. 26 other cubes, isn't it? You have 1 on each side. Yeah. 26. Yeah, because on a 2-dimensional it would be 8, but yeah. So we want to assert dot equal 26 fill dot count. And so this is gonna fail for sure because my fill is broken, but the idea is my fill five. So yeah, my fill is like super broken. Yeah, that's my fill is wrong. I think I really want pad 1. Why can't I seem to write breadth first search properly? Oh, hang on. If I don't want to go, if it said 5, my solution gave back 5 for my fill. So doing a fill with a single position 111, I got back 5 fill positions, which is really, really weird to me. So maybe I should look at what they are, but my fill is just wrong. So I'm just gonna print out what I'm doing here and look at it step by step. Box, bounding box, and then, well, I suppose I could use my debugger. That's really what I should do. Console.writeLine. I don't know why I can't seem to write breadth first search. I ran into this on day 12. I couldn't write breadth first search that day either. I blame my audience for distracting me. Mario, thank you for the follow. I hope you're learning. I hope you're growing. If you have any questions, don't hesitate to ask. Yeah, my breadth first search on day 12 was broken too, and I went through the crazy rabbit hole trying to figure that one out. I know. So I can't believe I can't remember how to do it right. Visiting, checking P. All right. Adding N. I know, it's just, I feel like I should just know how to do it. And I don't know why I can't seem to get it right. But we're gonna take a look here. We're gonna step through this bad boy here and see where we stop. Because if we have nothing less to visit, that's when we end. Otherwise, we keep anything. Yeah, I'm gonna put a debug in here now, but I just want these prints in here so that it'll show me while I'm debugging, so I don't have to like logic as hard. We're gonna debug this and see where we go wrong. Okay. We are filling here. Step over. What's my bounding box look like? There it is. My max X is wrong. And my min Z is wrong. So I just have... Remember when I said I was going to have a bug in my... there's going to be a copy paste bug? Let's go to bounding box. I have some min values mixed up here. Min X, min Y, min Z, max X, max Y, max Z. Min X, min Y, min Z. Min X is the minimum of my min X and my PX. Ooh, this is... Alright. Is my pad... What's my pad doing? Min X, min Y. Why is... That's wild. Min... There it is. There it is. My order is wrong in my construction. And Because I order them like this: max X, min Y, max Y, min Z, max Z. There it is. I was constructing my bounding box wrong. The order of my arguments is different. So, yeah, order of arguments. This is why having like a builder class is nice. Ugh. Let's see, did that fix that? Oh no, do I have an infinite loop? Oh, that's gonna force... Oh no, I don't. I don't have an infinite loop, but let's add a timeout to this. Still wrong, but... Yeah, have an infinite loop. Have an infinite loop. At least... Alright, let's keep debugging. My box is still wrong. Yeah, I need to do a step into my... Okay. I don't know. We're gonna find out, though. We're gonna find why it's wrong. So maybe maybe I got breadth first search right, but we're gonna step into this here and see where we're going wrong. Yeah, we're gonna all right. Our position 1, 1, 1. There's only one position in our shape, so it should be easy. These should all go to 1. And we return it. Alright. And then my pad is broken. For the exact same reason. Gah! Ugh. Name our Alright. Absk over on YouTube. Hello from America. Absk says hello, I'm from India. Welcome aboard, welcome aboard. We are trying to solve this here. Smab, quicker than me. I'm writing bugs because I can't get my bounding box. The order of my arguments, I can't get them to be correct. And we still have an infinite loop, it looks like, but let's keep debugging. Or I guess I could have checked what the error was here. Alright, is my bounding box right now? Jeez. Alright, my bounding box is now correct. My corner starts in the minimum possible. I add it to my visited, and then I add it to my queue to visit. I dequeue it. All right, I dequeue it. And then I crash? Whoa, I crash during this print statement. Oh, Desix over on YouTube saying hello, hello, nice to meet you. Absk, I don't quite understand your question. You're asking programming language, how easy to learn. Well, P is a position, so it should... Oh, it is... Yes. Public. We got a infinite recursion here on these. Public toString. I wish I could just stop being bad. X comma Y equals Y. Desix, I'm not making a video game today. We're doing Advent of Code puzzles. All right, does... Okay, all right. My super simple test pass. Let's get rid of these prints in here. But yeah, I'm not working on a video game today. I've done video games in the past. If you want to check out, I have some other live streams in the past doing some game jams. So if you're interested in checking out some of the games I've done, I've live streamed making several of the games over here. If you go back into my archive of live streams, you can watch me make those. But yeah, we are working on Advent of Code puzzles today. All right, let's run our program again on our example. See how we do. There we go. I have a little bit more confidence that it's going to work this time. And fingers crossed. Hey, hey! All right, day 18. Day 18 is not too bad. Not too bad if you can. So, all right, I'm super proud of myself. Well, let's. I managed to write breadth first search on the first try this time. Day 12 was a suffering day. Day 12 was a suffering day. Smab watched me write so many tests trying to figure out why my breadth first search was not working. I kept going, well, I even looked up breadth first search. But yeah, we got it. We got it here. Order of arguments. God. That was rough. That was rough. If I hadn't gotten there, this would have been an hour-long puzzle. I would have gotten through it really, really quickly. Yeah, gee, my flood fill skills have improved. I am now a master of 3D flooding. Yeah, so I will be making this one. This one's not too bad. A beginner guide for this one isn't too bad. It's a great opportunity to talk about flood filling or breadth first search on a 3D space, bounding box on a 3D space, and it's another breadth first search. It's another breadth first search, so really, really cool. Yeah, I feel like mine could use some refactoring too. Let me commit this real quick, and then we're going to take a look at yours, Smab. Beat implement day 18 part 2. Yeah, so day 16 part 2, my solution takes about a minute to run. I think I could figure out how to do my I ended up solving for like a 5-dimensional array. Absk's asking, what am I currently doing? We are working on, we just finished day 18 Advent of Code. This is a programming puzzle that we had to solve. So we just finished day 18. I'll send you a link. Desix asks, are you a full-time programmer? I am actually a computer science teacher. I teach computer science. Um, I've been programming for, I would say 25 plus years. I can never remember exactly at this point. 27 years, 28 years, something like that. But let's take a look here at, oh, look at those indents, those nice and short indents there. But yeah, I would say that I've worked in the past as a software engineer for a couple startups. So 10 years, I would say I was working as a software engineer, and I've been freelancing for 20 years, but employed by a company for 10. Let's take a look here. SMAB, let's see if we can focus. Always getting distracted. Always getting distracted. Streaming is fun. It's fun having people here to chat with and scrutinize my code. And then I'll open up my day 16 so we can look at my solution, which I don't think is the most efficient. Solution 1, yeah, solution 1's, that's it. Super straightforward. Just find the cubes that are adjacent there. How old am I? I think I'm 33. I'm either 33 or 34. Maybe 35. I kind of stopped counting. I was born in 1988. So fairly young, but I've been programming a long time. Yeah, so Desixt, I teach ages 7 to 17. My job is to teach ages 7 through 17, and I tutor some people a little bit older. I'm super young, Smab. Yes, I am. I'm super young. I have a long life of programming puzzles ahead of me. Solution 2. We get our cubes. And then we're going to build up processed cubes. All right. Number of exposed face is cubes times count times 6. And then we're going to reduce. Okay, so you shrink. You start saying, okay, these are all the exposed faces, and you're going to shrink that face. For each cube in cubes, get the adjacent cubes. If there is an adjacent cube, we go ahead and subtract that around. Oh. Adjacent cubes. So you didn't, let's keep looking here. Yeah, Desixt, I do it for pleasure, but I also, like, it is my full-time job is teaching young people to code. I work for a school. Let me add, just so people can see, I'm gonna put both the chats on the screen. I know it's a little crazy here, but we've got both Twitch and YouTube going here, just in case anyone's curious as to who I'm talking to. Yeah, that's fine. I was just reading through that, let myself get distracted. Nutella sandwich, hello YouTube. I normally don't get a lot of viewers on YouTube, but I like YouTube because they will keep my live streams forever. Twitch deletes your live streams after 14 days. So I like having an archive. New point. Process cubes here. Exterior queue. Okay, this is your breadth first search outside. This is your breadth first search outside. We check if it's outside. If it's on the outside, we continue. Yeah, we start on the outside exterior. Oh, this is neat. This is neat. Little solution here. You don't have to keep the bounding box like I did. You just sort of check to make sure you stay. You have like a I like a SMAB. Your solution is very similar to mine, but you're doing I feel like you're doing less work than me, because I go through and I like build up this whole set. Yours is just sort of saying whether or not you have set sort of on the outside. I really like your solution here, Smeb. Because you don't, I basically created, when I did my flood fill solver, I do a flood fill where I get all of the positions. Chandu, thanks for the follow. We're here doing Advent of Code Day 18 in C#. That's correct. Yeah, Smab, my fill, I build up a hash set of positions on the outside. Yeah, we've already finished Day 18. Chandu, sorry, so you missed all the action. So today was a relatively short one. You just missed it. We're going to talk a little bit about Day 16 in here in a minute, or at least my solution to Day 16. Because I have about 15 more minutes of stream time. Maybe 15 to 30. We'll see what we do. I have some lessons I'm teaching today. Absolutely watch previous streams, or if you want some guides on solving these, I have some guides that I've put together for days 1 through 14 so far. Yeah, Smab, that's what I was saying. Like, yours is really, really nice. Mine, I find sort of like the enclosing shape on the outside, and then I go through and say, okay, are any of these touching the outside? Well, I suppose I could also do the opposite, where I just have my flood fill on the outside and I say, I count the surface area inward. There's some different approaches to this. Yeah, Chandu, I'll walk through my code a bit here. I'll walk you through the code again. All right, so a little bit of review here. So the puzzle for day 18, we're trying to figure out, we have a bunch of positions for cubes in 3D space. So we have a bunch of positions for cubes in 3D space. And the first part is asking how many faces, so every cube has 6 faces, how many of those faces are not touching another cube, right? So if you have 2 cubes next to each other, the face that's touching is not exposed, so you want to count all of the cubes on the outside. So you want to see all the cubes on the outside. So all the faces that are exposed on the outside. So if you have 2 cubes touching, you have 10 faces exposed to the outside. So that's the first part of this puzzle. So I've created a position type, and my position, I should probably call this cube. It should be a cube because the cube is in a 3D space. So it's not really a position, it's a cube. And the cube has 6 neighbors, up, down, left, right, front, and back. So we have Z coordinates here, and I forgot to do my Z here. All right, so you have a cube, it has 6 sides. And then the first part's relatively easy to parse in. So I parse in all my cubes into a hash set. So I have a set of all my cubes. Okay. And then to count those exposed spaces, I loop through all of the cubes, and then I loop through all of their neighbors, and I say, hey, do any of these are any of these faces inside the set? If they're not, so if there's no neighbor on one of the sides, you increase exposed. Yeah. So n² solution. Exactly. Well, for every cube, hang on, is it n²? For every cube, you have to check 6 sides. So it's not quite, it's like, this is every cube, you check 6 sides. You're not checking against every other cube, because sets have we're using a hash set, so we look at a property of like O of, amortized O of 1. So if your hash is good. So it should be about O of n, where your constant size is the number of neighbors you have. All right, so we find all of our exposed faces. Trivial. So the first part of this is relatively straightforward if you're using a hash set like that. Okay, the second part, so it turns out your input set is a shape that is hollow. So there's inside of your shape, there's sort of a hollow space inside, and you could have pockets inside of that pocket too. So your shape is not solid. And so now it's saying, okay, well, we only want the exposure that's on the outside of your shape, right? So this one's a little harder. It's a little harder. So the solution I came up with was I create a bounding box. Let me switch to my document cam real quick. All right, so my idea here, let's see if we can get this to focus. Come on, I believe in you. So my idea here is that my shape is gonna be some cube that's inside of this box. All right. So if I can build a box around my shape, can I find the set of cubes that surround my shape, the smallest set of cubes? So I create a bounding box around it and expand it by 1, and then I do a flood fill, and I find all of the cubes that are around my shape. So I sort of have the inverse. I have like a mold. You can think of it as a mold around my shape. And then once I have that, I say, okay, for all of the cubes inside of my shape, are their faces touching the outside? And if they are, I count them. So we essentially do a breadth first search on the outside shape of our cube here, of our shape. And then we do a breadth first search, which essentially you can think of it as like filling it up with water and then checking where the water's touching. So ultimately, yeah, so it's like a mold that you're making. I've done like casting before, so it's like a mold surrounding it, and then you want to find where your shape's touching. So then I wrote a couple things. I wrote a bounding box. I wrote a bunch of bugs with bounding box. All right, so I wrote a bunch of bugs with my bounding box, but eventually I got it working. So I have a min x, max x, min y, max y, min z, max z. And then my solver, to do it, I take my set here, my cubes here. I find a bounding box and then I pad it by 1. So I gotta give a little extra space. And then I do a breadth first search, which essentially you can think of as filling up the space around it. So this is a breadth first search. I'm not gonna go into details on how that works, but we end up with all of the positions we can fit inside that shape. Once I have that, it becomes the same loop as before. So I take every cube, I find its neighbors, and then I check, are the neighbors touching the outside area, the mold? If they're touching the mold, my exposure goes up by 1. Otherwise, nothing. So that's part 2. This one is, what would that be? What would be the runtime? So this here, the runtime of this again is O of n, where n is the number of cubes. My fill to do a breadth first search. That's an interesting breadth first search. Is usually, I'm not stopping when I find something, so I have to go through potentially all of the spaces. Yeah. Yeah, my breadth first search is iterative. I use a queue. Like this. Breadth first search recursive. Is there a nice recursive version of breadth first search? I know for depth first search, if you want to do depth first search, you just swap this queue out with a stack. So the stack version, if I wanted it to do depth first search, I could totally do this. I just do a stack of positions instead and then push and pop. So depth first search is really easy recursively because you use the system stack. Anyway, so that's my recursion is recursion. I have a fondness for recursion. I think part of that just comes from doing a lot of work in functional programming. And tail call recursion essentially, it's less harder to read. So these are all interesting opinions. You can write really bad recursive code. Most languages, you're right, there's a mild performance hit you get with it because of the call stack. But you can implement things. There's something called tail call recursion, where if you're doing tail call recursion, your compiler should be able to turn it into a tight loop anyway. Oh, sweet. Let's take a look at your simplified version, Smab. Depends. Yeah, so like when recursion makes sense, it's nice to write recursion. So there's languages like Haskell where there is no loop structure. Everything has to be recursive. You use what are called higher order functions typically. So most of my loops here could be replaced with link calls, which is higher order functions. All right, Smab. Solution 2. All right. Ooh, okay. We find our bounding box. I should have just done this. I create my bounding box record caused me 30 minutes of debugging. My bounding box caused me 30 minutes of debugging. Beautiful loop here. Beautiful breadth first search. Nice tight code. This is my exact code. Mine, I have several more if statements, so if we compare these in my solver, my breadth first search, I could make these all ors. I don't know why I wrote it. I don't know why I chose to write it this way. Logically, in my brain, it kind of made sense to filter them separately. Oh, never mind. This is just checking your bounding box. That line, it keeps jumping down because I'm clicking over on that side there. This is bounding box here. That's my if statement for that. If contains adjacent, this is mine here. And then this is the one thing that's slightly different than mine. If it contains adjacent, if it doesn't contain it and the exterior tube does contain it. Oh, exterior exterior Q. Oh, interesting. Where is your... Oh, I see. You're building up an exterior queue. Oh, this is cool. Building up an exterior queue. Yeah. Sorry. I let myself get confused. I was trying to compare it to my solution, but you're doing slightly different. And then you loop over all the XY positions. Nice work, man. Yeah, I see. Cool. I know, I keep forgetting. I saw that. I even saw that. So it goes through the exterior queue and checks it. I like this. It's cool when you have puzzles that can be solved in like different ways. That was one of the things that I really liked about day 15 is how many different ways there were to solve day 15. All right, I'm gonna move YouTube back over here, out of the way onto my second monitor. Frozen collections. Are frozen collections just immutable collections? I haven't heard the term frozen collection, but it makes me think it's an immutable collection. Yeah. Gee, we were talking about day 16. Did I update my code at all here? Yeah, so having a performant immutable data structures is awesome. What did I change? Get reset. Oh, I changed the names. Okay, get status. Oh, I want to get diff here. Oh, I added that in. Okay. Oh, and I uncommented something? That's interesting. Console.writeLine. So it turns out for day 15, you can do... I was hemming and hawing over doing quad trees diagonally. You can do a quad tree that's not diagonal, it turns out. Do just regular coordinates, and you say your sensors just happen to contain things. Get rid of these right lines. All right, get status, get add, get commit, chore, change, fix toString. So let's look at day 16 real quick, because I didn't finish that one on stream. But a lot of people came up. Well, there's a lot of paths you don't have to check. So let's look at my part 1 solution. A lot of people did this interesting thing where they just found the best order for part 1, and then you can use that to say, oh well, if we just have the elephant go to the best part 2, and you sort of alternate who goes where. But that solution, there's a degenerate case in that solution that doesn't work for all outcomes. So here's my solution for day 16. Smab, I'm sorry if we're giving you spoilers for day 16. Anyone not familiar, day 16. Yeah, my initial solution thought I was thinking you could train more elephants, and it wasn't just 2, and so my initial solution was way wrong. Before I realized I just read the question incorrectly. Gotcha. So day 16 is a dynamic programming problem, right? So it's a backtracking / dynamic programming. My solution. All right, so let's say my solution is it. So really, it is a traveling salesman problem, right? So you want to find the best solution given a graph, and you have to visit all of the valves, right? You have to visit all of the valves. It's a traveling salesman problem. So this is not going to scale ever. So G, there's a degenerate case from yeah, there's a degenerate case from part 1 though. So that works it seems to work for everyone's solution. That's true. That if you take the optimal path for part 1 and do it, but there's this degenerate case where what if you have your starting room A and then there's 2 caves that go off in opposite directions, right? You have 2 caves that go off in opposite directions from A, and that have valves that are like pretty good as well. So like the solution, the solution is not. No. So Smab, the question is, you have 26 minutes to solve the puzzle. 26 is the number of minutes here. It does. So there's a degenerate case. You're saying find the optimal for one person in part 1, right? So find the optimal solution. If there's an optimal solution where you end up visiting just the right side of the cave. So let's say all right, let me go to my camera here. There's a degenerate case. So it turns out our puzzle none of the puzzles were challenging enough for it to be a problem. But the solution a lot of people came up to that was super fast doesn't work. There's a case where you can prove that there exists an alternate path that's better. So you start in room AA, right? So you start in room AA, and you have to shut off all of the valves. So it turns out that every puzzle has 15 working valves. Okay. It just so happens that what if
all of the valves, what if you split from AA, you have 2 paths, and 7 valves are on this path, and 8 valves are on this path, and there's enough movement over here that you never make your way back to this side. You shut off all the valves. There's like this really long path. So let's say we have a path like 15 steps to get over here, and there's like a really good valve that you can turn off on this side. Let's say that actually 14 of the valves are over here, and only 1 valve is over here. Okay, and there's a path over here that at the very, very end, it takes you, let's say it takes you 24 steps, and then you can turn off this valve, but this valve relieves, an infinite amount of pressure. All right, so if this valve relieves an infinite amount of pressure, you should always go there, and then you'll never actually be able to make it back to this side. All right, the case with the elephant where you have 2 people, one person should go this way, and then the other person should go this way, shutting off valves. So this is the degenerate case that it actually doesn't work for all possible inputs. It just so happens that all the inputs that people have, it happens to work on those. Okay, so the solution I have for part 1 it's not optimal path. It's all the optimal paths for one person shutting off the valves. It's all the optimal paths for shutting up one person shutting off the valves. Anyway, I'm not too worried about it. I have a solution. I'm going to show you my solution. Oh, sorry. I thought you were okay. I understand your solution now. Sorry, I misunderstood what you said you were doing. I thought, yes. Okay. Let me show you my solution though. So my state space happens to be this set of, my nodes happen to be this state space where I have the amount of time left, the position that I am in, and then the state of my valves. And then I do essentially a depth first search when I explore, but I memoize it. When I find a solution, I memoize it in here, saving that key. Yeah. And then my initial, you're right actually, that you can find the complement set. I have a 5-dimensional space for my second puzzle. So that's sort of my solution for day 16. Gotcha. I got confused on what you were saying. So some people basically selected they took their first path and then they used that to send their elephant to the best choices from there. But yeah, this solution runs in about a minute on my machine, so not too bad. And I just never went through and optimized it beyond that. I see. Yeah, that makes sense. All right. Okay, well. Yeah, my first solution for part 2 was wrong because I thought you could keep training elephants. And so my state space got big, it finished, but it was the wrong answer, and then I reread it, and I was wrong. I thought you could train an elephant, and that elephant could train other elephants, or the solution itself was like you could keep training elephants, and then you'd have as many searchers as you wanted. But there was this balance of training an elephant or going and exploring yourself, which was better, and that just wasn't the right solution. But yeah, I have this 5-dimensional space for my second solution. Finishes in 60 seconds on my machine. All right. Well, I think I'm gonna stop here. I've been streaming for a little over 2 hours. Thank you everyone for stopping in, hanging out. And you're always welcome back. Remember, you're always welcome back. If I'm gonna be streaming at least the next couple days. I'll be streaming Wake Up in Code 5 a.m. Arizona time. 5 a.m. Arizona time. So about this time. But yeah, have a beautiful day. Keep on coding. Keep on growing. And please, please never hesitate to stop on in. Bye-bye.